Hi, and welcome to the Value of Testing podcast. My name is Randy Rice. Good to have you with us today. Today, my topic is going to be why software testing foundations are still the foundations. You know, every few years, someone declares that software testing has changed so much that the old foundations just no longer matter. First, it was Agile, then DevOps. Test automation, of course, has been around for a long time, but it seems like there's always something new in test automation that people say is really going to revolutionize or change testing. Now we're looking at AI and Agentic AI, but here's the question. If the foundations no longer matter, why do the same failures keep occurring? Now, one thing I would like to think about here also, to just a question to ponder. If software testing foundations are obsolete, why are we still teaching them, and why do teams that ignore them keep making the same mistakes? So that's some of the territory I want to explore today. And I think that if we kind of get this in our DNA, so to speak, I think it's going to make us better testers, and I think it's going to add better value in our organizations. We know that change is constant. That's the one thing that doesn't change, is the constancy of change. Technology changes, development methods change, tools change, but the underlying principles of quality and risk have not changed. So first of all, what do I mean when I say the foundations of testing? I think back to some of the things we talk about in the ISTQB foundation level course. But of course, this can be found in other places too. But many of the things I'm going to just rattle off here are some of the big principles and foundations of software testing. One thing is that testing reveals information, but it doesn't provide any kind of guarantee of perfection. Another is that risk drives our testing priorities. Another one is that defects do tend to cluster. So when you find one defect, you can look around it and probably find some others. Early testing saves time and money. Also, independence of testing will provide additional perspectives on what you're testing. Coverage matters. The more you cover something, the better confidence you're going to have in it. But there's also a depth of coverage that we need to be thinking about. Requirements and expectations matter a lot. One of the very first lessons I learned when I first started getting into testing was that how in the world do I test something if I don't know what the expectations are, if I don't know what the rules are, if I don't know how something is supposed to behave. And then finally, testing supports decision making. One of the big goals of testing is, yes, we're here to find defects, but we're also here to provide good information to decision makers. Now, these principles, they were true in mainframe system testing, testing web applications, mobile apps, cloud systems, and they're still also true for AI. So I've been in this business of software development as a developer and as a tester, as a consultant, as a trainer for almost 50 years now, which means I've seen a lot. I have literally gone from punch cards to where we're at today. When I started out, everything was in that traditional waterfall model. And, it was very common back in those days not to do much testing at all. When I was working for a major bank, we made service charge changes into modules. I was the second middle guy, I guess. I was the middle guy on the checking account system for a bank that processed over 150 other banks. And it was just common practice for us to make changes, put them into production. No testing. We had no test environment, no test tools, nothing. In fact, in a corner of my cubicle, I shared a cubicle with the other two guys on the team, and by my desk I had a stack of printouts, probably 5 feet high, and the joke was that was my configuration management system. I would always take a printout of the current version and then have it there. I know it sounds crazy. Anyway, in that traditional waterfall world, there was a lot of cowboy coding going on, as they called it. A lot of spaghetti code being written. We wrote all the code that we had to fix in Y2K, basically. And testing was just kind of getting formed as a discipline all of itself back in the 70s, early 80s, and in fact, maybe the mid 80s. Then came client server. And in client server, there started to be a shift in how people saw testing. I was at a conference and one of the keynote speakers was from Microsoft, and he described how they did bug bashes and all of those kind of things and non-planned testing. And it was just alarming to people at the conference that someone would admit that they didn't have a test plan, they didn't have test scripts, but it was kind of in this time that exploratory testing started to emerge. Yet, the same principles of testing held the same, even though some of the methods might have changed. The basic principles and foundations pretty much remained the same. Then we get into the web, and man, things started going so much faster. We had to take better use of automation tools and those kind of things. We used to have the luxury of having a 6-week system test. Now we had to do it in maybe 2 weeks. Okay, but the principles remained the same. The speed got faster, the expectations got higher, the changes came faster, and all of that kind of prompted the emergence of Agile because the heavier weight kinds of documentation just simply could not keep up with the pace that Agile was being delivered in. Now, Agile did change some things in testing. It changed some of the terminology that we use. For example, an acceptance test was actually what we would typically call, in other contexts, a functional test. Not so much the traditional kind of user acceptance kind of test. We saw the testing pyramid emerge. We saw the testing quadrants emerge. Once again, just different ways to see testing, but the fundamental practice didn't change. Now in DevOps, that kind of did some things that I think was designed to even edge testing out, okay, and to force it to be more automated. Yet, the foundations are still the foundations. We're still practicing the same basic ways of doing testing, even in DevOps and continuous delivery. Cloud computing, it had some impacts. You know, we're not in control of what we're testing. You see a lot of software as a service in the cloud. And so therefore we have to be very mindful of the fact that what we test today may be changing tomorrow. And now we're in AI systems that are very non-deterministic. And I've written another blog post on crossing the line where I don't believe that agentic AI can truly be tested as we've seen it tested in the past. Now, there are many that might disagree with that, but the way I see agents being deployed, they are autonomous, they are out in production, and you never get a chance to intervene with them as a human. And so when do we even get a chance to test that? Now, testing in generative AI and those kind of things, that's a little bit different story. But even with all of that, we're still talking about things like boundary value analysis, equivalence partitioning. We can still use decision tables. Many of the techniques, we can do exploratory testing and all that. Many of the techniques that we're using throughout the journey of testing still remain the same. And the interesting thing is, in each one of the technologies and SDLC changes that I've just mentioned, there were all these predictions that testing would fundamentally change. But that never really happened. Yes, it did change in some ways, but it didn't totally upend everything. Agile was probably the biggest sea change that I can really think of, and it increased speed, but you know, we still create test cases based with the same thought process. We do automation. pretty much in the same way. In fact, we're still struggling in many cases with test automation. So, testers are still asking, over the years, these questions remain. What could go wrong? What is the risk? What should we test, and how much testing is enough? In other words, when do we stop testing? Well, I want to kind of talk a little bit about how some of our modern techniques are actually based on some classic principles. The first one being risk-based testing. That has been around since in the web, really, as far as a practice. In fact, I remember creating a course on risk-based client server testing. So it goes back to probably the mid-90s, at least, when we were really first forming this as a practice. It's not really new, but it's the same way of prioritizing things that testers have always used. You test your big and important stuff first, and then you go down to your lesser and lesser and lesser risk items. Shift left, this is kind of an interesting one in my opinion. Shift left is just all about doing things earlier than waiting until the end of a release to do any kind of testing. The funny thing about that is it's considered to be kind of a recent development, but it's been around since the mainframe days. The idea of doing reviews, walkthroughs, early unit testing, all of that, it was just kind of given a term, given a name in more recent years. But the economics haven't changed. The things that we're looking for haven't changed. I am glad that the awareness came about. But be clear, it's not a new thing as far as people who practice testing are concerned. Automation is kind of a thing, too, to think about. Automation has been around since the mainframe days. In fact, I used to work tech support for a mainframe tool company, a test automation tool company. Then a big shift happened in client server, and of course, then the web, the tools had to change. The principle, though, behind automation even remained the same. Now, we saw some interesting advances within test automation. We saw these long linear scripts. It was quickly realized that those were unsustainable, that they required a lot of maintenance and all that. So people started breaking those long linear sequential scripts into more modular scripts and have a driver script then to invoke the modular scripts. And then they parameterized the test so that the hard data wasn't in the scripting. That was supplied from an external source. So then we got into data-driven testing. And then finally, the next major leap in terms of frameworks are concerned would be the keyword-driven approach, where it kind of builds on modularity and data-driven test, and it will then use some kind of action word or keyword to invoke the correct test at the correct time. So we've seen some advances within test automation, yet people still struggle with it. The tools come and go. Tools come, they disappear, they get bought, they go into non-support, all kind of risk around that. But the main principle around automation is it doesn't tell you what to test. You have to take your test to the tools and then create the automation around your test designs. Now, we do have some tooling that can help you come up with those test designs. For example, you can have a tool that will create pairwise test cases that you could probably then import into a test automation tool to some degree. But still, for the most part, the tools don't tell you what to test. That's all up to you as a tester to prioritize. The idea of continuous testing. We have the same goals here: to detect defects, reduce risk, to support release decisions. The idea, though, is that these are primarily lighter tests, and I think as any tester who's been in the field for a while will say it's always good to keep on testing because you never know what you're going to find. So the idea of continuous testing, though, really to be sustainable, needs to be automated. And then you have AI-assisted testing, which is where we're at today, where AI can help generate the test, and you tell it the test designs you want to use, or at least what the requirements are, and it can not only review the requirements for you, but it can also generate the test. Now, the humans have to still decide, we as testers have to decide what's important among those tests, what's risky, what do even our success indicators look like, and the tests that are being generated, are they good tests? Are they rigorous tests? Are they even correct tests? We still have to give some critical review to the things that AI can help us do in testing. So, if anything, I think AI makes foundations more important and not less. You know, one of the things that we discover with AI is that it increases uncertainty, because most of your traditional systems are pretty deterministic. It's cause and effect. And I used to joke around when I would teach classes that, testing is kind of like working down a list. If you take a methodical approach, you do this and you expect to see this. You have that going on in the history of technology, but now we've seen this big shift into AI, which these systems are more determined by probability. They're non-deterministic and many times very unpredictable, because the AI can be making decisions that you're not even aware that it's making. And when the AI model changes, then that can undercut everything that you've done in all of your previous tests. So in AI, it's really important that we do a good risk analysis and even contingency planning. You can ask questions like, well, what happens if the AI is wrong? And I can assure you that the probability of that is going to be pretty high. How severe is the impact if it does get something wrong, or if it does hallucinate? Now, by the way, my personal opinion about hallucinations are that they are basically defects. People call them hallucinations, but it's just because that's an AI term and it's fabricating stuff. So in a way, it's kind of like it's lying to you. And then also, how likely is the failure in AI? Well, it depends on what you're doing and how often you're doing it. But if we're going into this age of agentic AI, the failure could be highly likely. Now, test design still matters. I mean, AI can create thousands of tests, but consider that maybe 1,000 poorly designed tests are still 1,000 poorly designed tests. And I would rather have 100 well-defined tests than 1,000 just random test cases out there. So there's an elegance of test design. And I always tell people when I'm training that test design is a very nuanced thing. You can teach it in a classroom, you can read about it in a book, but it's not until you go about and actually start practicing it do you see just some of the fine points of test design and really what makes it all work together. And many times AI misses this completely. It doesn't really pick up on the nuances. So one other thing to think about here too is, what is a test? The idea of a test is that you're actually executing test in a controlled environment. There's some repeatability around it, and you can know in a safe place whether or not something works or not. And that's true for just about any kind of test, whether it's software testing or vehicle testing or anything. Now, we talk about blood test and blood pressure test and all that. That's more like a monitoring, an evaluation, an assessment. And that's kind of where we're at when it comes to AI testing. If we're talking especially about agentic AI, once that agent is in the real world, making real world decisions, think, for example, about the self-driving car, a Waymo or something, then we have to know, we have to monitor, we have to have ways to intervene. I saw a video just recently about how a Waymo got in the way of a fire truck trying to respond to a fire. And the first responders had to get in touch with tech support so that they could actually move the car out of the road, or help them move the car out of the road, so that the fire truck could get past it and go to the fire. Apparently that wasn't part of the Waymo's programming or something. Anyway, once you have this agent out there making real world decisions, or series of agents, it's not just an agent, then yes, you have to spend a lot more time monitoring what's going on in production. That's valuable. Observability is also valuable, but neither one of those replaces testing. With agentic AI, you never get the chance to test exactly in the sandbox. Even if you go back to the non-deterministic nature of AI as a reason for that. There are a few misconceptions I want to address real quickly here. The first one is that AI will eliminate testers. Now, the reality is that AI may eliminate some test activities, and maybe testers who have just gotten used to checking a box or doing simple tasks and considering that their job, they may be at risk. But AI does not eliminate the quality risk. And I think companies are going to learn that that risk still exists, and we still need people who can work to assess that risk. Another myth is that automation replaces test design. The reality there is that automation only performs what you tell it to perform. It does not create the test for you. There are some tools that do create some tests, but you still have to curate those tests, and you still have to give some thought to those. So it's the humans that think about what's going to be tested and what kind of designs are needed. Another myth is that Agile changed the testing fundamentals. Well, the reality is that yes, Agile changed timing and collaboration, how people work together, maybe some of the terminology, but it really never changed the purpose of testing. And then the fourth and final myth here is that experience no longer matters. The reality here is that technology is always changing, but your judgment remains valuable. As I mentioned in a previous podcast, this is where there's a lot of anxiety in people, that they're being told they have to use AI, and in doing so, they feel like that AI is eroding their experience, their skills, their judgment, and that should never happen. That should never be the case. So I just kind of want to end here about some things that I've noticed in my 40 plus years in testing. Keep in mind, I had about 10 plus years before that in development. But, you know, I kind of imagine myself sometimes as the guy sitting by the road watching a parade go by. And you see all different kinds of things come down the road. You see technologies that emerge, then they disappear. You see new tools that come on the scene, they disappear. I've seen people make huge investments in a particular tool, and it just goes away. They had to pivot and redo all their tests for a tool that disappeared. I've also observed that there's a lot of principles that remain. Even programming languages come and go. I've seen the methodologies come and go. I've seen testing tools come and go. But I still see teams succeed when they understand the important things like risk, coverage, quality, and the struggle when they don't succeed. So those things are still very important. Now, before you chase the next trend, whether it be AI or anything, ask yourself, do you have the fundamentals in place? That is things like understanding risk, designing meaningful tests, learning what it is you're testing, the system, being able to measure what really matters in your test, and then using AI and automation wisely. I guess if I had to close with one thought, it would be that the foundations of software testing aren't just old ideas that survived by accident. They're the foundations because every new technology keeps proving them right. So I really hope that this helped maybe clarify some things. I hope that it reinforced some things. By the way, the date of this recording here is around the middle of June 2026. I have some foundation level classes that are going to form, live virtual classes in August and September. You can find out more about those at mysoftwaretesting.com. I also have e-learning for foundation level testing that you can take anytime, anywhere. You can take at your own pace, and that's a very popular way to learn the foundations of software testing. It's the ISTQB certification, which is very valuable and meaningful for people. So I hope that, once again, this clarifies that the foundations are still things that we need to be using and thinking about, that AI is not going to totally replace those. Well, thanks a lot for watching, and I look forward to seeing you next time.